All right, so let's do some examples. So example 2, it gives us this triangle, and it says to avoid round-off errors when using calculator, you will store unrounded values in your memory. So funny, I need to update that. Because we can use Desmos, we won't have to do that. But so you'll see I have Desmos on the side here. Please use Desmos because it will make your life much easier than trying to use old calculators. Um, so to go back to what we talked about in the previous video, across from your little a is angle A, across from little b is angle B, and across from little c, your hypotenuse, is angle C. Really important, that's always the case. So then we know for A, I'm telling you that B is 4, so we know this value is 4, and then angle B is 10 degrees. We need to pay attention to the instructions, solve the right triangle. So you need to figure out all the values you don't know. So looking at that, I don't know side length A, I don't know side length C. I don't know angle A, but I could figure out angle A because the triangle adds to 180, and you're going to take away the two angles that are given. So what do we get? 80 degrees. Does that make sense? Another way you could write that is 180, take away the 10, take away the 90. Both are A-okay. So now I know that this is 80 degrees. So now what I'm missing is C and A. So you have to make a decision of what you want to solve for first. There is no rhyme or reason. There is, though, strategy in you want to make sure you stand at the 10 degrees. Because if you just calculated things wrong, so say you got this 80 wrong, then everything will be wrong. So always stand at the angle that was given to you in the problem. So now it's just up to you. I'm going to decide for us that we solve for A first. Well, if I'm standing at the 10 degrees, A is what to me? Adjacent. And what is forward to the 10 degrees? Opposite. And the C is the hypotenuse. That is always the same, no matter where your theta is located. So if I'm standing at 10 degrees and A is adjacent and B is opposite, you want to ask yourself, from SOHCAHTOA, which one deals with opposite and adjacent? Well, it's going to be the TOA. So that's what forces me to use tangent of your degree equals, and again, it's TOA, so it's opposite over your adjacent, which is your A. Well, I need to solve for A, but A is in the denominator, so I'm going to multiply both sides by A. So I have A times tangent of 10 degrees equals 4, and then you isolate the A by dividing by tangent of 10 degrees. So far I have A equals 4 divided by tangent of 10 degrees. I do not know what that is, okay? Tangent is a pretty complex function, so you would have to use a calculator. And looking on your right side of the screen, you'll see I have Desmos up. It's a Desmos Scientific Calculator. You can find this link in Desire to Learn. If you change this value, see how it goes from degree to rad? That's radian. We don't know anything about radian, so make sure it says DEG on your calculator. And so I'm just going to put it in just like I see it. 4 divided by, there's my tangent value, or function I should say, of 10 degrees. And then I close it, and we get A is approximately 22 point, and just go to the hundredths. We'll just make that. Make sure you're paying attention in MyMathLab what they want you to round to, because they do change it up on us. So it looks like it would be 6.9. So the length of A is 22.69. So now we have to find C still, all right? Again, I'm not going to use, oh, that's my dog. He's saying hi. I'm not going to use 22.69 because I rounded it. So that's what that box, excuse me, that's what that box up there is saying. So it's saying don't use a rounded value because then everything will be off. All right, so I'm going to go ahead and I'm going to stand at the 10 degrees again. But now, let's give me another color. I am going to use my opposite and C. I'm not going to touch this 22.69 because if it's wrong, then everything will be off. And then also I rounded it, so everything will be off. Well, if I'm standing at 10 degrees, which one deals with opposite and hypotenuse? Well, that would be so, because opposite and hypotenuse is there. So I'm going to do sine of 10 degrees equals opposite over hypotenuse. Okay, so maybe you want to pause the video and see if you can solve this on your own. Multiply both sides by C. And then isolate the C. So we get C is 4 divided by sine of 10 degrees. So if I use Desmos, because I have to, I'm going to get out of here. 4 divided by sine of 10 gives me 23.04. So there we go. We solved for everything unknown. We know side length A, we know side length B, we know side length C, and we know all the angles. Okay, let's do one more example. And this is saying C is 9 and B is 20. So this is based off 20 degrees, I should say. This is based off this triangle. Okay, we wrote all over it from the previous problem. So I'm going to draw it again down here. So I have something to go off of. And make sure my labels are right. So this is A, B, C. So following the rules, okay, so angle C, angle A, angle B. So they're telling us that C is 9 and B is 20 degrees. All right, if I need to solve for this triangle, that means I need to find angle A, side length B, and side length A. To solve for a triangle means you have to solve for everything unknown. All right, well, I can solve for A just like I did in the previous problem. So angle A is 180 degrees, take away 20 degrees and the 90 degrees. So it looks like I get, that would give me 110, so I get 70 degrees. Okay, well now, once again, I'm going to stand at the 20, just in case I butchered that 70. And it's whatever you want to solve for first. I'm going to choose A. A is adjacent, and I'm given the hypotenuse. So if I'm going off of this again, which one deals with adjacent and hypotenuse? That would be ka. So that's why it's cosine of 20 degrees equals adjacent over hypotenuse. Well, if I want to isolate the A, I multiply both sides by 9. So I get 9 times cosine of 20 degrees equals A. And then I need to get my calculator. So I'm going to go to Desmos Scientific. And let's see if I can make this work. There we go. Okay. So I'm going to go here and I'm going to say 9 times cosine. Make sure you're in degrees. Now my cat's saying hi. Of 10. And it looks like we get A is approximately, and make sure you tell your readers you're rounding, 8.86. Now we solve for B. Again, I'm going to hang out at the 20 degrees. I am not going to use this 8.86 because it's rounded. So if I'm standing at 20 degrees and I want to find B, that's opposite, and I have hypotenuse, so I'm going to use the sine. So sine of 20 degrees equals B over 9. And you go ahead and solve and make sure you get the same thing I get. So I'm going back here. 9 times sine of 20 degrees. And I get 3.07. Oh, no, 3.08. Whoops, don't want to do that. I don't know what happened. There we go. 3.08. So let's make sense of this. Remember, let me just make that look a little more clear. Across from your small angle is your smallest side. Across from your biggest angle is your biggest side. So across from 20 degrees is 3.08. That makes sense. And across from 70 degrees is much larger. So yeah. All right, so now you practice some in my math lab, and then we will go to the next section.